Okay, now we want to talk about why are mountains tall. And the first thing is it depends on how thick the crust is. So the thicker the crust, the higher the mountain is going to be. And the way to think about this is with an ice cube. So imagine that you got two ice cubes, and so one is this thick, and then you got another ice cube that's only this thick. Well, one thing, if you take the ice cube and you put it into water, what you find is that about 9/10 of the ice cube is underwater, and about 1/10 of the ice cube is above the water. So you can see why icebergs are so dangerous, is that you can't see all of this ice that's under the water. But with this ice cube over here, if you take it and you put it into water, what you find is the same percentage is above the water and is below the water. But notice that since this one is thinner than this one, then when I draw the level of the water, do you see that this has to be thinner than this one over here? So that again, 1/10 of this ice cube is sticking out of the water, and then 9/10 of it is below. So let's say that this is 10 centimeters thick. So then that would mean 1 centimeter would be above, and then 9 centimeters would be below. But let's say that this one over here is only 5 centimeters thick. So then that would mean that 0.5 centimeters would be above, and then 4.5 centimeters would be below. So less of it is going to stick up out of the water because it's thinner than this one over here. And so if you've got a mountain system, so here, let's say if you've got a mountain that's like this, well, it turns out that a mountain has a root, just like this piece of ice here. And so this mountain is kind of like floating in the mantle. And it has a deep root that goes down, and just a small amount of that mountain is sticking up out of the ground. And then as it is eroding, what will happen is the top part is going to get smaller, but so will the root. And so what will happen is the same percentage below the surface of the earth is going to be the same in both of these pictures here. All right, the second reason why mountains are tall is it depends on what the mountain is made of. So is the mountain made of granite, or is the mountain made of basalt? Less dense regions are going to float higher than the more dense regions. So that's the reason why that, for example, mountains are composed of granite and they stick up out of the ground, whereas basalt, which is dense material, is on the ocean floor. So it doesn't stick up out of the ground as much. Okay, then it also depends on the temperature. So that hot regions where material is coming up is going to push up the ground, so hot regions are going to be higher. And then finally, imagine you've got two rugs and you're going to push the two rugs together. They're going to get crumpled together, and so crumpled areas are going to be topographically higher. So what causes domes and basins? So domes are again going to be where the area is pushed up like this. So that could occur at an active margin where you've got two plates that are being pushed together. Okay, it also could happen as a result of folding and faulting. So notice that this looks like an anticline from the sideways view. So as these materials being pushed together, it's going to be making a fold, and then that fold can push up the ground above it and turn it into a dome. Also, the third picture shows a magma plume coming up, and again, that can push the ground up. Now, basins are going to be areas where material off of a mountain is filling in an area. So at a passive margin, that's where the plates are being pulled apart. So new ocean floor is being formed. So next to the continent, where this continent is moving in this direction away from the mid-ocean ridge, material off this mountain starts to fill in this area. So that's a passive margin. Continental rifting. So we said that where the plates are being pulled apart, you have normal faulting where the rocks are falling into this place where they're being pulled apart. So again, material can fill in that low spot, and then that would be a basin. Okay, this time instead of an anticline, you could have a situation where you have a syncline, and then material can fill in the syncline, and then that would be a basin. And then finally, you could have a situation where originally you had the ground was like this, and there was a mountain over here, and it's shedding material onto this area, so it's getting more and more material, and so eventually the ground begins to sag under the weight of all that material, and so that makes a basin. All right, let's take a break and let's talk about next what an exotic terrain is.